Well, good afternoon, everybody, and welcome back to the Johnson Space Center here in Houston. Joining us is Leroy Kane. He is the chairman of the mission management team. He's also the deputy manager of the Space Shuttle program. He'll talk to you about the events of the meeting today, and then we'll take questions here and then out on the phone bridge. I'll turn it over to Leroy.
Okay, thank you, Kyle. Well, good afternoon. It's good to be back with you again today. The crew is doing very well on orbit. I don't have a lot to tell you with respect to the mission management team today. We did talk only briefly about a few items. The crew on orbit was busy today doing some transfer, doing some preparation for their spacewalk tomorrow, and just generally getting ready for flight day 5. Today was a pretty busy in-cabin day, and so but we did have a couple of things to talk about in the mission management team meeting. The assessment teams had an opportunity to look over all of the inspection data, and they brought in their report, and I'm happy to report that there was really not very much to talk about at all. Literally, we had just very few areas where they were able to detect any kind of damage at all, and maybe I'll bring the pictures in tomorrow. I probably should have brought them today, but for today, I'll just give you an example. We have a couple areas where we have some very minor blanket damage, and these are things on the order of an inch by a fraction of an inch on an ohms pod, a gap filler that has a little bit of sleeving that you've seen around the gap fillers. A little bit of the sleeving is protruding, and that's on one of the ohms pod areas. We had 2 tiles that they looked at on the bottom, in the entire bottom side of the orbiter, where we have thousands of tiles. We had 2 tiles that they looked at, and the damage is just coating damage on the order of a couple of inches by a couple of inches. Just phenomenal. The performance of the entire space shuttle system to result in this kind of a report from the inspection team. So it's true that we've gotten pretty used to and have enjoyed for a number of flights increasingly improved performance as a result of all the work that the team has done on the vehicle and the vehicle elements to improve the overall performance of the system. And it's not as though I'm surprised by this. I'm not. It is that I'm not sure we generally talk about it in these terms, and we like to show you pictures of areas where we've had damage, for example, and talk about why it's not a concern. I decided not to bring the pictures today because it really is such trivial damage that I didn't think they'd be of interest, and then it was pointed out to me that might actually be a good point to make. So at any rate, we talked over all of the results with the team, and their recommendation is that we don't have any requirement for a focused inspection that we typically talk a great deal about. And as I mentioned to you the last time we were here, so our decision officially is that we will not do a focused inspection. We have no areas of concern to require any kind of focused or more detailed inspection, so we won't be doing any of that. So again, I can't say enough about the engineering team and the work that they did to get through all this data in the last couple of days. I think it points out again something we talked about the other day, where the team really has evolved as we've gotten more data on the ground, and when you consider the volume of the data that the team goes through on any one of these flights, it really is pretty phenomenal. And even to the point of their processes for reviewing this data has evolved and been refined, and it's really pretty fascinating to watch them go through their process and bring the results forward. So the Discovery continues to perform excellent. We really only have very minor things to talk about from a system standpoint, nothing significant at all, nothing that we're concerned about. It was the team mentioned that the boosters are in tow. Matter of fact, I think we expect them to be in the port tonight. They'll be in the slip tomorrow on Monday, and then we anticipate that we'll do open assessment on the boosters on Tuesday. And so we look forward to those results. We have a great deal of cryo margin on the order of 2 days. And And so, as you know, there are some things we want to do to include possibly a +1 day for the Soyuz fly around and some other transfer activity that we might want to do, as well as we would like to transfer as much O2 as we can. So we'll look at doing that. And it looks like we're going to have every opportunity to transfer as much O2 as probably as the station can take. So with that, our plan is still that we will talk about the Soyuz fly around in the MMT and then the IMMT, and then we'll make an integrated decision there probably somewhere on the order of Tuesday morning coming out of the IMMT. I anticipate we'll have a decision about whether we're going to do the fly around or not, at least from the standpoint of whether it's technically feasible and whether or not we think we can go do it from an operational standpoint. So that's the plan forward. It's been another outstanding day in space so far. I was talking to one of my colleagues and I asked, what I want to talk about today. What can I tell folks? And he said that I should tell them that we plan well and that we take one day at a time. And clearly, we're doing that on this mission as we have on previous ones. So, with that, I'll be happy to answer your questions.
Okay, we've got a few folks here, and then out on the phone bridge. Start with Bill.
Bill Harwood, CBS, with a real quick one. I think you addressed this earlier at a different briefing, but just to make sure, if the fly around does not get approved, do you guys have any task that would make you want to add that day if the rest of the mission continues to go smoothly?
I think, Bill, that we probably will because there's a great deal of outfitting where the PMM is concerned, most of which the team has done an outstanding job of getting all that integrated into the timeline. But what I find generally is that on these kinds of missions in particular, we can usually find things for the crew to do if we're able to see our way to staying another day. So I fully expect that there's some good work that we can do on orbit with the station team if we stay for an additional day, even the Soyuz fly around notwithstanding.
Thanks. And one more quick one from me on debris assessment. Realizing that you don't see anything in the RPM photography, have you learned anything that lets you modify or change how you think about the timing of debris events, not in terms of when things come off, but when things pose a threat to the shield? I mean, obviously these guys had some contact and didn't do anything, which would fit your theory going in about the aerodynamically sensitive transport zone and all that. Is there anything you've seen that makes you modify any of that, or is it all pretty much by the book at this point?
That's a good question. I would say, I'd probably say it, and maybe this will get to your question in a slightly different way. What we have seen, I would say, in many ways substantiates what we think is happening. For example, the other day when I was here, we talked about 3 or 4 events or debris events. And as it turns out, and our thinking was that the ones that we had seen up to that point were ones that they occurred well outside of ASTT, the area of aerodynamic sensitivity where you can actually put some energy into a particle and do some damage. These all occurred outside of ASTT. So you wouldn't expect that even if they did come in contact with a vehicle that there's enough energy there to do any damage. Well, in fact, we're not seeing any damage. And we do know that we had some, albeit a very small number from what we could see in the imagery, particles flying around. And again, late in the profile, late enough that it's outside of our area of concern. So that sort of reinforces the way we look at areas of concern and times of debris liberation. So, Bill, I would say what we've seen substantiates the theories that we've been putting forward, and it substantiates the areas that we've put the most emphasis on in terms of trying to make modifications to the vehicle so that we can minimize, not only minimize debris liberation, but minimize the effects of debris when it does liberate in areas where we just have done everything we can, but we can't make it zero.
Mark?
Thanks, Mark Carreau for Aviation Week. I think I just want to be clear, has the image team then sort of finished its assessment of all the launch imagery and the wing scans and the RPM photography? I mean, as far as you guys are concerned, Discovery has a good TPS system, right? I mean, I just didn't know whether it's final or there's some formal process that has to yet take place.
Yeah, we're several steps into the process, and we just passed the step where we like to be able to make a decision about focused inspection. And the reason that step is where it is in the sequence is because while we do bookkeep some time for focused inspection, it's a very nominal amount of time, and we never know pre-flight how much you're going to need for a focused inspection. And so you like to keep those kind of issues, you like to keep enough runway in front of you to deal with anything like that. So therefore we front load the process with this screening such that we can get as early as possible a decision about whether or not there's some area that we want to go look at in a more detailed fashion. However, that isn't, in fact, the end of their work. It isn't the end of the process for reviewing imagery, for reviewing inspection data, for reviewing the data from the wing leading edge impact detection system. That goes on for a couple of more days. And in the case of the wing leading edge system, we have it on and off periodically throughout the on-orbit operation, so that will go on through the end. But back to the imagery and the analysis of the imagery and the respective inspection data, that goes on, and it will continue to be reviewed at the next level, if you will, and then more peer review happens after that. And at some point here in the next 24 to 48 hours, I anticipate that we'll make a decision to clear the vehicle for safe deorbit and entry. And so that's kind of the time frame that we're looking at.
Anybody else? Phil?
Philip Sloss with NASASpaceflight.com. Just a quick question on the cryo margins. Is that above the nominal docked timeline, or would that be above the nominal plus the extension day?
Right now, that's above the nominal. And so the 1 day will come out of that. And then if we did anything beyond the O2 transfer that we currently have planned, it would also come out of that.
Okay, thank you.
You're welcome.
Robert.
Robert Perlman with CollectSpace.com. With regards to the Soyuz flyabout, has the actual flight plan over what you're considering right now reached a solid point where you're now just reviewing just one flight path for it, or is it still in flux? And to your knowledge, have early plans been sent up to Scott Kelly and the crew to start reviewing in the case that if it is approved, they can perform it?
Yeah, good questions both. On the second one first, we have been talking to the on-orbit crew since the inception of this, so going on through somewhere between 3 and 4 weeks now, to include at first very rudimentary plans, and as of late more detailed discussion about the actual timeline and the events and the sequence and choreography of things. So yes, very much the on-orbit crew has been integral in this since we started talking about it. To your first question, we have pretty well potted the plan for what we would do on flight day 10, the plus 1 day, with respect to the Soyuz fly around. So we know when in the timeline we would do it, the sequence of events leading up to it in the morning, when it finishes, what the other on-orbit crew members are doing during that time frame, what we do with hatches afterwards and getting crew members situated in the vehicles and things of the like. So it's pretty firmly in place. I won't say that we won't tweak it between now and then, because I'm 100% sure we will, because that's what we do. But it's pretty well ready to go.
And with regards to the crew on orbit, have they taken any steps in terms of starting to set up the Soyuz to support it?
I'm not sure how much they've done in the actual Soyuz vehicle. I know they've done some things in terms of laying out equipment and procedures, and talked about techniques and seating positions and timing of things. But I don't know how much, if anything, they've actually done in situ in the vehicle.
Denise, you have anything? Right over here.
Anna Shakeen with Harvard Journalism. If you do get to do the flyover and you take that wonderful image, in your own words, what does that image say?
Oh, wow. I probably should have thought about this question before you asked me. The truth is, I've been thinking about that since we started talking about it. Not how I would answer this question, but what it would mean, what it might mean, not to me, but to all of us. And you know, the space station is an amazing research laboratory. And if you think about what it took to get the modules in orbit, to get them constructed, and to build this facility that we have orbiting and manned 24/7, and now 6 crew members, it's pretty eye-watering and mind-boggling. And I think that perhaps because those of us who have been around it and been a part of it still believe and are still fascinated by how amazing it is that we, the broader team, have been able to accomplish this on the international stage, and with all that is required in order to do that. I think the fact that we are still pretty fascinated and amazed by it tells me that if the average person in the public, who probably is not as familiar with most of it as we are, arguably, any opportunity we have to help them see what it is we've really done and what it means to us as not just as a nation, but as an international family of space communities, that can only be a good thing. I really truly believe that can only be a good thing. I think there's probably a lot of folks who maybe really just don't, they hear us talk about it. They understand on some level what it is we're talking about with respect to whether it's a space shuttle mission to the station or the station itself orbiting 24/7, doing important research, big laboratory, a lot of complicated structures, etc. They probably don't have an appreciation that we might like for them to have. And something like this image might go a long ways toward improving that overall understanding. Now, having said that, while I do admittedly very much like the fact that we might actually capture some of these images if we're able to do this fly around, it really will be important and valuable for us from an engineering and technical understanding of the entire station standpoint. We're motivated to do it because we're going to get some views and some perspectives and some engineering data on the station that we've yet to do. Now, you might think after 10 or 12 or 13 years we probably would have done some of this by now, but we haven't for a broad myriad of reasons that we could go into. But rather than do that, I'll just tell you this will provide us some pretty unique views, some pretty unique engineering data, and it would be extremely valuable for us to have that. And yes, it would be very neat and I think valuable for me personally, obviously, but much, much, much more importantly than that, for the country and for all of the nations who are involved to have it and be able to look back on what I believe will be one of the greatest legacies of the space shuttle system, that in fact being the space station.
Anything else? Okay. Let's go to the phone bridge. I think we got 2 folks online. We'll go with Marcia Dunn first.
Yes, hi, Leroy. I was wondering, is 4 still a good number for the debris event? And I'm wondering, were you ever able to ascertain whether all 4 were foam?
I only caught part of your question, Marcia, but I think I know what you asked. And no, I don't have any more information for you on the 4 events than what we had the other day.
4 is still a good number. Is that the extent of what's been found so far?
Yes. That's correct, Marcia.
Thank you. That's all from me.
Okay. Irene Klotz, are you on?
Thanks. Yes, I just have one little out-of-the-box question. Leroy, is April still looking like a good target launch for STS-134, or are you guys looking at moving that to June?
Yes, April looks really good for us for the Endeavour mission, STS-134. And we feel really good about the schedule going forward. And actually, we have quite an extensive launch period in that mid-April to early May timeframe. So we feel pretty good about that.
Okay, that's it for the phone bridge. So Jeremiah, let's see, we'll get Pete right here and then Mark, and we'll wrap it up.
Thanks. Pete Spots with the Christian Science Monitor. I wonder if you would just sort of give an example of the kind of engineering data you think engineering insights you might be able to glean from images. I think when people tend to think of engineering analyses, they think of placing sensors somewhere and taking all sorts of measurements. Can you give an example of what the photos might tell you?
Sure. Yeah. As you know, typically when we approach the station as a shuttle or when we leave, or same thing for some of the other visiting vehicles, whether it be Soyuz or one of the other vehicles, the vehicle approaches or leaves in plane with the long axis of the station, where the solar arrays are out of plane. And so, for example, in this case, when we do the fly around, we're going to get a vantage point that's going to look kind of down the long axis of the truss and have a different view of the solar arrays and of the entire long axis of the station that we haven't had before. So if you think about some of the things that the station program has had to be concerned with in the past, to include radiator panel damage or MMOD damage, we're going to get a different vantage point, I think, that's going to offer them some new data that may suggest this is another area that we should be looking at differently than what we have been. Or here we had some shielding, and it appears to have been a really good idea to have shielding in this area. Maybe we should have some more in another different area. Things of that nature, for sure, will be, I think, provided with this rather unique vantage point. So in that sense, that's one example of some data that could be used, some good engineering data for the station team.
And Mark, we'll wrap up with you.
Thank you again, Mark Carreau for Aviation Week. And I just want to touch back on the cryo margin. Is it likely to grow even more? 2 days at this point is pretty healthy. And if it did, would you look at more than 1 day extra at the station if you found something to do, or is that kind of tops?
Let's see, Mark. I don't expect it to grow much more. One of the reasons why, and a lot of times we do see a little bit of growth the first couple of days after we get on orbit, and we really look at the performance of the fuel cells with the power transfer system hooked up. And then the power experts will go in, the folks that manage the fuel cells on the ground, excuse me, and they'll make some changes to their calibration curves that they use in their models for predicting performance and for predicting cryogenic margins. And when they do that, it usually gives us a plus up because we're more conservative with the cals initially. So that's part of what you're seeing, is that plus up as a result of the normal calibration tweaking that we oftentimes do. In addition to that, we're going to start using it up because of transfer at some point here in the not too distant future. And in addition to that, we're kind of at the point where we usually otherwise level off. So I won't be shocked if we have some additional small increase, but I don't really expect it. To your other question, if we do have margin that would allow us to do something beyond or in addition to a +1, that is to say, add a second +1 day, I don't know whether we will do that or not. Certainly, if we had a need for it, after we had already used up the first +1, if we determine we have a need for it and we have a cryo for it, we'll make that trade as we always do and do a risk versus risk-based assessment and make the decision based on that. So it wouldn't be out of the question by any means. I think if if the performance of the vehicles and the mission to this point is any indication of the rest of the mission, I wouldn't anticipate us doing that, but we both know that's not an indication of the rest of the mission. So.
All right, let's see, we'll close with the usual couple of programming notes. Crew heads to bed about 9:30 tonight, and then we'll begin our Flight Day Highlights package replay starting at 10. This is Central Time. Crew wakes up tomorrow morning at 5:23 to begin the preparations for EVA number 1. That starts around 6 a.m., and then the EVA is scheduled to start a little after 10 o'clock, a 6.5-hour excursion. And then our next briefing in here will be after the EVA, of course, and that will be about 7 p.m. tomorrow, tied to the end of the EVA. So head back here for that briefing. All of that's on the NASA television schedule out on the web, so take a look for that, www.nasa.gov/shuttle-TV. And with that, we'll thank everybody for coming. Have a great rest of your Sunday. Thanks, Leroy. And we'll head back to Mission Control and back to space.